So in picking out one last topic in physics, I thought let's go ahead and talk about waves, just generally waves. And actually, when we talk about astronomy, we're going to need to talk a little bit about light. And I think what little bit we talk about with regard to light is going to help us down the road. So a good way to think of a wave is the wave that's generated, for instance, as you drop a pebble in a pond. And where the pebble hits the water, it imparts energy to the water, and that water then moves out in all directions. Oh, I guess I should say a wave. And that moving out in all directions, that is actually the energy that is relocating outward from where you drop the pebble. Okay? So if you were to watch the ripple, okay, you would see that it would be the water's going up and down, up and down. If you're into fishing at all, you throw a bobber out there and you can see that bobber go up and down. Okay, so actually that up and down is the wave that is propagating through the water. The water's the medium, and it is going at what we say a right angle. The movement of the particle is at a right angle relative to the motion of the energy outward. And that actually makes this type of wave what we call a transverse wave. I'll kind of highlight that at the bottom here. Transverse wave. I'm going to show you another type of wave here in a minute. But what waves have in common is that if you take one repeating unit, and we're going to go from crest, the top of the wave, to the top of the next wave, from crest to crest, that distance is what we call the wavelength. Between the crests we have the trough. Okay, so kind of you see here called the still water level is kind of the middle here, and actually that is going to show us what we call amplitude coming up. All right, so that's a transverse wave, is the movement of the particle, in this case water, is up and down, perpendicular relative to the movement of the energy, the wave radially out. All right, so the other type of wave is a longitudinal wave. And if you take a slinky, and here's your hand over here, and you basically give the slinky pulses, pulse, 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 okay? And what you're doing are creating these little compressions, and we're going to call those compressions, and regions of, this is rarefactions, I think, where it's open, and that's another type of wave. In this case, the water is not the medium, but the medium actually is the slinky. And let's see a picture here. We have the wavelength, just like the wavelength before we took from trough to trough. We can take a wavelength of this sort of longitudinal wave by going from compression to compression, or rarefaction. Make sure I pronounce that right. Rarefaction to rarefaction. That's just like the middle of where it's the least dense. Okay, so this is called, oops, sorry, let me go back. I want to highlight that. This is called the longitudinal type of wave instead of transverse. Longitudinal means that the movement of the particle is in the same direction as the movement of the energy.